So we have completed 3 stages of our 4-stage travel demand model, right? The first stage is the first stage of the 4-stage travel demand model is generation, trip generation. Then second, distribution. Third, more choice. Now the fourth one is traffic assignment. So okay, what do you understand by traffic assignment? Or what is your understanding about traffic assignment? What we are going to do in traffic assignment? Hmm? What is your understanding about traffic assignment? Diversion of vehicles. Okay. To control the flow. Not exactly to control the flow of vehicle, but to assess the flow of vehicle. How actually, like for example, we now know that these many trips are going to go from point A to point B. Now, right? Now you tell me, like there are how many possible routes available to you to reach to this exhibition hall from your hostel? How many possible routes are there? 3, 4. So technically speaking, there are infinite routes, right? So let me give you an example. For example, if you want to travel from Vijayawada to Delhi by a flight, okay? So how many routes are available? One is a direct flight from Vijayawada to Delhi. Second one is first you go to Hyderabad, that is Vijayawada to Hyderabad, then take a direct flight from Hyderabad to Delhi. Third one is you take a flight from Vijayawada to Mumbai, then you go to Delhi, right? You go from Vijayawada to, let's say, Bangalore, then you go to Delhi, right? So technically speaking, there can be n number of different routes available or infinite sets of route available for you to actually reach your destination, right? But are we really bothered about all the available routes, or we are only bothered about, one or two or three specific routes? We are only bothered about very few specific routes, right? Why? Time, right? So there are only 2 to 3 routes that are available to us generally, which have relatively same amount of time. The shortest path, everyone is going to prefer the shortest path, right? If you want to travel from point A to point B, you are going to prefer the shortest path, right? If let's say the shortest path is loaded, then you will look for alternative routes, right? And if that alternative route is also loaded in the sense, a lot of people are traveling on that route, then you will look for some sort of other alternative route. But in general, you will look for the feasibility of 4 to 5 different routes, right? So in traffic assignment, the same thing is done. So what we are going to assess is, let's say if point A and point B, I want to travel from point A to point B. So one thing that I have to do first analysis, or I have to develop an understanding, firstly, which is the shortest path, because most of the people are going to use the shortest path. Now, if the shortest path is loaded, meaning a lot of people are traveling on the shortest path, right? And if it is loaded, then definitely the people who want to travel in future, or let's say after 10 minutes, they get to know this information that this path is loaded, so they will be looking for some alternative path, right? And if this route is also loaded, or we can call it as the second shortest path, if this is also loaded, then you will look for some other alternative routes, right? So on and so forth, you will be keep identifying. So in general, what you are observing over here, that as the traffic on a specific route increases, what is happening? The travel time on this route will increase, right? For example, if I want to go from here to Vijayawada airport, so if I have a direct road available or direct connecting road available, on that road during evening, because that road is also serving a lot of commercial areas and all, right? It is very loaded. So I will look for some alternative route so that I will diverge, or if I will change my route in a way so that I can reach my destination, right? So first thing, I will be giving highest preference to the shortest path. Then eventually I will look for other options that are available, but the travel time might be slightly higher than the free flow condition, meaning free flow traffic condition of the shortest path, right? If there was no traffic on the shortest path, I would have taken shortest path. Now the traffic has come over here and the shortest path travel time has increased. Let's say initially if there is no traffic on the shortest path, it would take you 15 minutes. Okay. Now as the traffic has induced on the shortest path, because everyone is using the shortest path, this 15 minutes will increase to 30 minutes. But if I have an alternative route which is not loaded currently and it is providing me a travel time of, let's say, 25 minutes during peak hour, so which route I'm going to take? 25 minutes, because now this is the shortest path for me, technically speaking, right? Now let's say if a lot of people have started thinking like me and now they are taking the second route, so what will happen? The 25 minutes will go high and it can reach up till again 30 minutes, right? Because the traffic has induced. As we know, if the congestion starts, the time will increase, right? Now this has reached till 30 minutes. Now a person who is planning to travel to point B from A, he sees this is 30 minute, this is 30 minute. What is the travel time available to me for the third route? Let me explore that. And if you have been provided with the information that now it is 28 minutes, as such there is no traffic and it is 28 minutes. Now that person will take which route? 28 minutes, meaning again they will look for the shortest path, right? This will be happening over the complete period of time. And over the time, what will happen? All the traffic that you have assumed will start from A to B will be assigned in a way that all the routes eventually will have same travel time, right? After reaching a point of congestion, every route will have same travel time. This is 30, this is 30. Now someone has started at this route, slightly the traffic will again increase, so this will also become 30. So eventually what has happened? On all the routes, initially the free flow travel time were different. This is free flow travel time, 15 minutes, 25 minutes, 28 minutes. Free flow travel time meaning if there is no traffic, how much time you have to invest to reach to destination A, to destination B, right? This is free flow travel time. But once we have loaded the network or the routes, the free flow travel time will increase and eventually this whole state will reach into an equilibrium condition. This is known as an equilibrium condition. Now anyone who is coming, let's say there are three people. The first person was here, the travel time increased from 15 to 30 minutes. The next person who saw that available route is 25, he took this route, second person. But again, because of him, the travel time increased from 25 minutes to 30 minutes. The third person now had an option that 28 minutes is available to him, right? He took this route. The travel time increased from 28 minutes to 30 minutes. Now the fourth person that will be coming. What? How you are going to again load the fourth person? Because the travel time is more or less same, right? If he takes first route also, the travel time is 30 minutes. If he takes second route also, the travel time is 30 minutes. And if he takes third route also, the travel time is 30 minutes, right? So to assess how much load we can provide on our network so that the travel time reaches a state of equilibrium. This is a state of equilibrium, right? By all the three routes, you have same travel time. So how much loading we should be giving on each route so that finally we reach a state of equilibrium or a saturation. So in a way that as such all the available route has the same level of travel time. And by exchanging of trip, no person is going to gain a better output. Meaning if someone thinks that I will shift from this route to this route, is he going to get benefited? No, right? This is 30 minutes. If he thinks that I will shift to this route, 30 will, for this particular route, 30 will increase to 32 minutes. There is no gain for him to shift, right? So this is a state of equilibrium. Now we want to identify when we load our network how we are going to reach a state of equilibrium. What is the load that we can provide on this link? What is the load we can provide on this link? And what is the load we can provide on this link in order to reach a level of equilibrium condition? Okay, and that is what we have to deal with, which is known as a traffic assignment problem. Okay, so eventually, slowly and gradually, we will be loading our network, seeing how the travel time increases. If the travel time increases, then we will shift the traffic to some other direction, right? If in that route also the travel time increases, we will again shift the traffic in another direction, and somehow we reach a saturation point where the travel time for all the three routes available is more or less the same. Okay, this is what we want or we are aiming to do in traffic assignment. Okay, so these are some of the general terminology that we will be using in traffic assignment. For example, we will be first understanding how many number of trips we can assign between I and j at for route r. Okay, then what will be the flow, meaning between this set of I and j, how much traffic we can induce. Now on each link, we, this is, let us assume this is link number 2, what volume we can assign v2 here. This is link number 1, what volume v1 we can assign on this link, and here what volume we can assign on this link, right? And we know that v1 plus v2 plus v3 will be sum equal to tijr, right? The number of people who are willing to travel from point A to point B, right? So that sort of assessment we want to do. Okay, so we are going to show, and this each and every route is a link. Right now we are assuming that each and every route is a link. So what we want to assess is link flow on each link, how much flow we have to assign. Secondly, what is the cost association of that particular link. So for example, if this link is a 4-lane highway, and if you add 10 vehicles on 4-lane highway, the travel time will increase drastically? No, right? But if it is a single lane road, and if you add 10 vehicle on a single lane road itself, right, within, let's say 30 seconds, if you are adding 10 vehicles on a single lane road, the travel time will drastically increase on a single lane road. But is the travel time being impacted on a 4-lane road? No, because the capacity available for a 4-lane road is very high, whereas the capacity available for a single lane road is very less, right? So there is an association that how time is going to get influenced with respect to a function of volume on that link. That association we have to understand, okay, with certain assumption. So what do you think? What sort of association you are going to observe, or what is the association? Let's say in this case we put cost equals to time. Okay, so how the cost is associated with the link flow? How the cost, if you want to draw a graph, or if you want to say that okay, the link flow will be associated in this fashion with the cost, how you are going to assume that association, or what sort of uh, association you are going to assume? It has to be sort of a increasing function, right? Increasing function in the sense, if the flow on a link increases, the travel time also increases. That makes sense, right? If more number of vehicles are present on a road, the travel time to travel from A to B will also be increased. If no vehicle is present in front of you, the travel time will be less for you, right? So we tend to see this type of association where this is flow on link A and this is cost on link A. And this makes sense also if you see technically. Why? Because when you are dealing and this particular, okay, what will be this value? Tell me. This particular value, or irrespective of cost, I will write time. Okay, time and cost are same in this case. What will be this value? This will be a free flow travel time, meaning if no vehicle is available, how much time you have to spend to cover that particular link, right? Because here technically speaking, no vehicle is available, no flow. So what is that minimum time you will face to cover that link, right? There will be some sort of a minimum time, even though the traffic is not there. But if you want to cover a link, there will be a sort of a minimum time, right? But we know that this time is going to be more or less same for less amount of traffic, and then as you reach a state of congestion, what happens? The travel time for that link increases drastically. And congestion meaning too many vehicles, right? Congestion meaning there are too many vehicles or too much of flow is there on the link, and because of that the travel time on that link increases drastically or exponentially. Okay, so this sort of assumption we assume as a link cost function. This is a link cost function which is dependent on the flow of the, okay. So based on this assumption and the understanding that people are going to choose a route which is shorter or shortest to them, we are going to do a traffic assignment problem, okay. So this is what we were talking previously. So the travel time on a specific link, meaning what is the travel time? Time per kilometer. Right now we are quantifying. If I am saying there is 1 kilometer link or length of the link is 1 kilometer, so what will be the travel time for that particular link is going to be drastically increased if the flow is higher. If the flow is very less, you don't see any vehicle in front of you, the travel time will be the free flow travel time condition, okay. Now what sort of association this, can I quantify it using some sort of equation, right? So a very standard equation which is given in literature is this equation: E equals to T naught 1 plus alpha V by Q to the power beta. If you see technically, if V is the link flow, if V equals to 0, what you are getting in this? If V equals to 0, V is link flow. If V equals to 0, so what you are getting in this? T naught. T naught is nothing but a free flow travel time condition. To cover 1 kilometer of distance, normally we can assume 60 kilometer per hour is the speed or desired speed on such network, right? If you have nothing in front of you, you might be driving at a speed of 60-70 kilometer per hour, right? So you are going to spend at least 1 minute to cover 1 kilometer. So T naught is somewhere around 0.75 minutes, right? Which is close to 1 minute, right? This alpha and beta are the calibrating model or calibrating parameters, right? If a particular link or a particular highway is very much sensitive to increase in traffic, then the values of alpha and beta will be increased, okay. So these are calibrated through literature. You can assume, based on certain literature, like for highway it will be different, for a freeway it will be different, for a local road it will be different, okay. And if you see Q, what is Q? Q is the capacity of that particular link, right? Which is normally assumed to be 3600, okay, in PCU, okay. Now once you reach a level of capacity, so V by Q will be One, the volume flow on the link is equals to capacity. So V by Q will be 1. So if you see what amount of increase you are going to see in the travel time, it will be twice, right? V by C or V by Q equals to 1. Let us assume beta equals to 1 in this case. So the actual travel time once you reach the capacity will be twice of that of free flow condition. So meaning previously if you used to take 10 minutes when there was no traffic, because of the system running at capacity, the travel time will be 20 minutes, right? So this is how you have to infer this equation. Now we are going to use this equation and the methodology related to traffic assignment to understand how to assign different flows to different conditions. Okay, so this is just an example that tells you why this sort of association makes sense. Because let's say if you see at capacity, which is this point, right, very close to 3500, right, if you increase the flow by 10 units or if you increase the flow by 100 units, what is the increase in travel time? It is very high or relatively high compared to this case where you have not reached capacity, right? You are in free flow type of a condition or less number of vehicle. Now you increase the flow, let's say from 1500 to again 100 units of flow you have induced into your system, that is 1500 to 1600. The increase in travel time is very less. Can you see? And this makes sense also, meaning initially what will happen if there is no vehicle and if you have given 100 vehicles on the road per hour, the travel time will not change significantly. But if there is an existing condition of capacity, meaning you have already there are already 3000 vehicles on the road, and now if you have increased only 100 vehicles on the road, drastically you will see a significant increase in the travel time. Okay, so this sort of assumption or this sort of association are important, and how to calibrate them will depend on the type of the road that you have considering. Okay, now what are the inputs in general for the traffic assignment? Firstly, you have to give the trip matrix, meaning how many people are willing to travel from one place to another place. This 100 units we have assumed, right? This has come from the trip distribution output. Using the trip distribution output, we got an idea this many people are willing to travel from point A to point B. From mode choice, we will further get an idea that how many people are actually willing to travel by car, how many people are willing to travel by bus, how many people are willing to travel by train, right? And if since train is not the part of the network, meaning not the part of the highway network, I'm going to just assume these many people who are traveling by car, bus, two-wheeler, I'm going to assign them on the routes of the highway network. Okay, so this is the input that is needed to me, that how many people are going to use a highway network. Second will be the network, how many, because of the network we know how well it will be connected to the destination, whether there are three different directly connected route, parallel route, or D route type of a possibility that will be given information to us using the network. If the network has three different route like this which are running more or less in parallel, right, there is a possibility that the network has altogether different route. If this is a hilly terrain, so the network is derouting yourself, right? If these two cities are connected by an hilly terrain in between, there will be no direct connectivity, so you have to deroute. So because this information is also important to us, okay, what are the options available to you? So one is how many people are willing to travel from point A to point B. Second one is the network, and third one is the rule of selecting a route. What do I mean by rule of selecting a route? I mean that based on what logic people are selecting a route, whether they are selecting the route based on the shortest path of travel time, whether they are selecting the route based on the shortest cost, meaning if there is a toll, so now time and toll, you are going to weigh both of them together. If there is no toll on both the routes, so only time is that component based on which you are going to assume how people are going to travel. or which route you are going to choose. Only time is that factor. If there is a toll in one route and there is no toll on other route, right? Then what you are going to do? You are going to measure how much additional time I have to spend if I'm taking a road which has no toll. If I'm taking a road which has toll, how much cost I have to pay in order to save some time. Let's say if I'm saving 40 minutes of my time, is it worth to pay that toll, right? So I'm weighing, I'm developing some set of rules for myself, how I'm going to choose one route over the other, right? So these rules are known as thumb of rule when while choosing a particular route, okay? So based on these three different logics or based on three different inputs, we are going to perform the traffic assignment, okay? So you are going to see more about how to, represent your network, particularly related to right now the software we are dealing with. They themselves are doing a coding your network, right? But what is the actual logic behind developing your network? If let's say you want to perform the same exercise in Python without using Visum, right? If you want to do the same analysis in Python, so how you are going to code your network? So this is a representation to code your network, meaning firstly you have to identify the centroid of the zones. So this is zones 1, 2, 3, 4, right? So you have to identify the centroid of the zone, or you have to give a value related to the centroid of the zone. Secondly, you have to identify the nodes. What are nodes? Nodes are points that are connecting the links, and links are nothing but the representation of your highway, okay? So you have to code in your Excel sheet, okay, this is how I'm defining my node, this is how I'm defining the centroid of the zone, this is how I'm defining the link, okay? So in general, if I want to define a link, I can use two information, meaning which two nodes it is connecting. How to define a link? A link can be defined by 2 points, right? So if I want to define this link, so what I can do is the point it is connecting or the nodes it is connecting. So node number 14 and 15. If I write node 14 comma 15, that will automatically assume that there is a link, okay? Then corresponding to that link, what is the time that I'm going to face if I use that link? What will be the cost that I'm going to see if I use that link? Or you can also represent it, what is the capacity of that link? Because we know that different highways or different type of roads, right? This can be a representation where this is a national highway and other are state highways, right? So automatically there will be a difference in capacity. So you can denote that attribute of the network either by the time it is going to take or the capacity that is available on that particular link. Is it clear how to represent the network in general? Okay. Although most of the things are automatically done for you in general when you use sim related software or other planning related software. But the basic logic behind how they tend to develop the network is based on this. Okay. Now let us take an example. Whenever we want to assess or whenever we want to do a traffic assignment related problem, the first thing that will be how we are assigning our traffic based on the shortest path, right? Everyone is taking a route which has the shortest travel time, right? So now let us solve a problem, and I want to travel from point 1 to 6. How you are going to identify which is the shortest path? So you have two options, right? If you start from 1, either reach 2 or reach or go to 3. Then from 3, I will go to 5, and 5, I will reach 6. This is one route available to me. Second, 1 to 2, 2 to 4, 4 to 6. This is second route available to me. Third, 1 to 2, 2 to 3, 3 to 4, 4 to 6. So you are understanding there are many combinations available to me. But which one I am going to choose? I am going to choose the shorter one, or the shortest path I am going to choose, right, to reach 6. Now how to solve this problem? Either you identify all the possible combination of route, calculate their time, and then highlight, okay, this is the shortest path. But this is, although this is a toy network, right, where there are only 6 nodes and 6, 7 links. Solving them manually for you, it may just take half an hour or something like that, right? But when we deal at city level, where there are, 1,000 links, 1,000 nodes, then it is very difficult to do that manual calculation. There has to be certain logic behind it, which can solve the problem for us, and then we can get the answer. So this is known as Dijkstra's algorithm, which is the backbone of finding out the shortest path. A lot of softwares are directly using Dijkstra's algorithm to find the shortest path. Okay, and how the Dijkstra's algorithm works, and it has a lot of application. In general, you see electrical, you see mechanical, you see computer science, because you have to transfer information, right? In computer science, what you are doing indirectly, you are transforming information from a server to some unit, right? So that also the information that has to be passed on should also follow the shortest path, so that there is a, less resistance to the information, right? So everyone is using the shortest path algorithm, and Dijkstra's algorithm is very, widely used in a lot of application related to engineering and sciences. Okay, so I will give you an example how to actually solve a Dijkstra's algorithm. So what we will be doing, the point from which we are starting, we will mark it as 0, because okay, rest all other points we will mark infinity, meaning reaching there from 1 is going to take infinite time, reaching there from 1 is going to take infinite time, all other nodes I have marked infinite time, right? The basic assumption, right? And since I'm starting from 1, so the travel time to reach 1 is 0, because I've started from 1, right? Now what I will be doing is I will be updating this network, meaning which is the shortest point or the nearest point that I can reach from 1, which is the nearest point, 2 or 3. This is travel time. So if I start from 1, it is going to take 2 minutes. If I start from 1 to 2, it is going to take 4 minutes. So which is the closest point to me based on this time? 3. So what I will be doing, I will be updating my network. So instead of infinity, I will be writing 2. Rest all will be same. Okay, meaning infinity, infinity, infinity. So I have updated my information. Rest all are infinity. 1 के लिए 0 है, 2 के लिए, sorry, 3 के लिए I have put 2, right? Now I will start from 3. Okay. Now what are the options available for me to travel from 3? Either I can reach 2, or I can reach 5, or I can reach 4. If you are standing at 3, these 3 different routes are available to you. Now what I will be doing is I will be updating those information. Okay. So if I start from 3, which is the nearest point that I'm going to reach, this is going to take 1 unit, right? This is going to take 8 minutes, right? This is going to take 10 minutes, right? So on and so forth. So I will update my travel time. So at 2, now either I will get 3, meaning the travel time will be 2 units of travel time previously you faced, and if you want to reach again point number 2, you will face additional 1 minute, which will be 3. Or if I start from 1 itself to reach 2, how much travel time I have to face? 4, right? So I'm going to do that, and I'm going to update. Once that time is fixed for you, meaning this is the shortest time now you can reach to point 3, so you will freeze this. Now you will look into the combination or available travel time to other different nodes. Okay, so we will be redoing this exercise again and again. That means infinite, somehow we have to update the information related to infinity, okay, which we have assumed previously, and we will keep doing it, right? So as I've said previously, if you travel from 1 to 2, so you have to face 4 minutes. But if you travel from 1 to 3 and then 2, what is the travel time? It is 3 minutes. So I have cancelled 4 minutes and I have updated it as 3 minutes, right? Now I will freeze this value. of 3 minutes, because 3 minutes is the shortest time available to me to reach point 2, right? Now I will look like from what are the other points available. I will start from that point. Let's reach point number 4. Okay, so this is 3 minutes previously, and if I travel using this link, which is going to take 5 units of time, it will be 3 plus 5 8. This is 3 minutes, sorry 2 minutes, 2 plus 8 10, which is the shortest path, this one. So instead of 10, I've cancelled 10 and I've used 8 as the shortest travel time. Okay, so now I will freeze that number because 8 is the minimum travel time. Other than, lesser than 8, I'm not getting by choosing any of the routes, right? Now to reach point number 6, this is 2 minutes. If you reach point number 5, either 10 plus 2 12, or here it is 8, 8 plus 2 10, which is the shortest one. So this, then this, right? So 12 you have discarded and you have assumed or fixed a value of 10 units. Okay, once you have freezed it, now to reach point number 6, 8 plus 6 14, or 10 plus 3 13. So you have updated it, right? So finally we got it, that the minimum travel time which is required for me to travel from point 1 to point number 6 is 13 units, right? And I have also identified the route associated to it. Okay, the route is, first you travel from 1, go to 3, then travel to 2, then go to 4, then travel to 5, and then go to 6. Now you can do your own calculation, meaning let's say if you assume that, okay, I will assume this seems to be a direct route, right? Let me do the calculation for you. 4 plus 5 9, 9 plus 6 15. That means it is not the shortest, because shortest is 14. That means whatever we have solved is correct, right? So based on this logic, which is known as Descartes algorithm, you can identify the shortest route. Okay, and this logic is normally used by the computers to solve the shortest route, and they can solve the problem very quickly using this logic. Okay, now we have identified the shortest route, right? So what we will be doing every time, we will be assigning traffic to the shortest route. We know that once the shortest route or the traffic assignment is done on the shortest route, the travel time on the shortest route will increase. Then automatically what will happen? For example, in this case, let's say you assign a traffic on this, okay, which is 13 units, right? Now suddenly what happens? Everyone is going to choose this route, which is the shortest route. But the traffic, if the traffic is induced, the travel time will increase, right? So now this link, instead of 2 minutes, it will become 4 minutes, right? And then you solve the problem again, then you will identify now this has become the shortest route. Okay, because 2 minutes here increase, let us assume 3 minutes of increase over here, 3 minutes of increase over here. So this 13 will become, let's say 18 or 19. But we know in the network there is another route available which is 16 minutes. So now people will start choosing this particular route. So what the software will be doing in background is every time it will be running this Dijkstra's algorithm, update the travel time. Again it will run the Dijkstra's algorithm. You induce some traffic, it will increase the travel time slightly, run the Dijkstra's algorithm, assign traffic to it. Again, if you induce more traffic, the travel time has increased, so it will change the route. Okay, now this is not anymore the shortest path. This is another route is the shortest path. Again, it will be keep doing it unless and until all these links on this network are loaded. And for each and every link, we will get the flow. Okay, at this flow condition, this is the maximum travel time. At this flow condition, this is the maximum travel time. And traffic assignment is going to do that only. So is it clear how the traffic assignment will work in the background in the software. Okay. In general, and what are the different type of traffic assignment? So there are different categories in which you can do your analysis. So there can be stochastic effect included or not. You can have two different category. What do you mean by stochastic? Stochasticity. Have you heard about stochasticity before? Stochasticity mean more of a uncertainty or information which is provided to you. How much certain are you about that information, right? So in today's world, how I will get to know that the travel time like is not because of the traffic it has increased from 28 to 30. Google Map is telling me, right? So that information is available to me using Google Maps, right? Previously, when Google Maps were not there, everyone used to take the shortest path because the perceived as such, no one is providing them information. If there is a lot of traffic on this road, right? If you don't have that information, everyone used to take the shortest path, right? And other two routes, they were not loaded at all, right? But in today's world, when we have a good information, right, uncertainty is less. So we are able to rearrange our traffic in a way through this particular network we can pull in maximum flow, right? Otherwise, let's say 30 years back, there are three different routes available to you, and you are always traveling on the shortest route. Someday you see some sort of accident on the shortest route. So everyone will be stuck on the shortest route unless and until information is passed to the users at this point that there is an accident over there. We have to deroute, otherwise the travel time will be increasing or will keep on increasing, right? But nowadays Google Map is giving us that information that okay, the traffic or there is a lot of congestion ahead, it's better if you deroute yourself, right? So on particularly on this bridges, you might have seen this, right? So normally what happens, if this is city A and city B and there is a flyover, this hello, hello. So I'm just giving you an example of all or nothing. What you will be doing, like for example in the previous case, we have identified the shortest path. All the 100 units of flow you are going to assign to the shortest path. Okay. And a better model, optimization based better model, is a user equilibrium principle. Based on user equilibrium principle, what it says that we will develop a function. Okay. Have you heard about optimization before? How many of you have heard about optimization? You have heard. Or in general life you might have heard, right? Optimized route, best path possible, optimal solution, right? This is the optimal choice that I have made, the best choice I have made. So in optimization, what we do, we make a decision based on a certain, objective function which we want to either minimize or maximize. For example, if I want to travel, so my objective will be to minimize the cost related to travel, to minimize the travel time, right? This will be my objective, to minimize overall cost, right? But if I want to, let's say, gain money, so I want to maximize my profit, right? So what are the things that I should be doing to maximize my profit, right? Or an organization which is planning to build a, manufacturing unit. So to optimize their profit, they will be identifying that how much, machineries we should buy, how much human resources is needed, how much people we have to hire, right? What is the salary that we have to pay them. So in general, what I'm going to do, I'm minimizing my cost and maximizing my profit. Okay, so this is known as optimization. Okay, so this is the objective function. First you identify what is the objective function. The variable which are going to influence the objective function are known as decision variable. Okay, so if I hire more people, what will happen? The amount of salary that I have to pay will be more, my profit will reduce. So what is that optimal number of people that I should hire for my organization? So number of people, hiring number of people is a decision variable. Okay, and there are constraints. When I say constraints, meaning minimum I have to have 10 people to, run this office. So this is a constraint I have put on my function. So in an optimization problem, there are three aspects. One is objective function. How do you write your objective function? In my case, let us assume my objective is to maximize my profit. What are my decision variable? How many people I have to hire to maximize my profit? But I have put a constraint that minimum 10 people I have to hire so that I can run this office, right? The same way, if we see traffic assignment problem, what we can do is we can assign the traffic in a way that the overall travel time in the network is minimum. Are you understanding what I'm telling? The overall travel time in the network is minimum. So how do I quantify overall travel time? Number of flow on a link and what is the travel time associated to this, plus number of flow on another link and what is the travel time associated to this. Okay, so if there are three different links A, B, C, and there are three different flow conditions VA, VB, VC. So what is the total travel time? Will be, it will be VA into TA plus VB into TB plus VC into TC. This is the total travel time of the system, right? Somehow I have to assign traffic in a way that this thing is minimum, right? This thing is minimum. So that is what is done normally with the optimization model. We want to minimize this particular function, right? So if you guys are aware about this integration, integration is what? You sum it over all the information, right? Small part ka you sum, right? Integration is nothing but sum of small parts, right? And this small parts, you have to do it for all the links. How many links are available? Over all the links, that is over all the A's. If there are 3 links, you have to do it for 3 links. If there are 100 links, you have to do this for 100 links. So this particular function you have to minimize and you have to identify the value of VA, VB, VC. Okay? Is it clear how mathematically you can solve this optimization problem? Okay, so this is a typical example. So as we have seen previously, link cost function, this is an example. There are two, let's say I want to travel from point O to D. There are two different routes available to me, and this is the link cost function associated to each and every route. Meaning, if you load link 1 too much, then at 10 units of flow, the travel time will go 1000. Okay, and if you load link 2 too much, that is at 10 unit of flow, the travel time will go 200. So what is the optimal flow that you have to assign, right? So let us understand this problem. If I assume in this case, what is the free flow travel time for link 1? 10. What is the free flow travel time for link 2? 20. So based on my logic, if I assign most of the traffic, okay, most of the traffic to link 1, so what will happen? As I induce 1000, or if I induce 100 units of flow on link 1, what will happen? My travel time will increase to 1000, right? So it is not a good advice, or it is not good to induce all my traffic to link 1. What I can do, I can induce some traffic to link 1 and some traffic to link 2, so that the overall travel time of the system is kept minimum. Got it? So here what I will be doing, if you see, if you solve this problem, if you solve this problem particularly, it will be somewhere around 6 or 5 unit, sorry, 6 unit of flow you are going to assign to link 1, and 4 units of flow you are going to assign to link 2. That is the best optimal solution, in which the overall travel time of the system is minimum. Okay. So now we have solved these three stages, and using the traffic assignment, we are going to identify that which are the routes that people are going to take, different routes. So we have solved for traffic assignment as well. So all the four stages are clear to everyone, how, what is the modeling logic behind all the four stages, and if you have to perform a specific stage at your own level for your thesis or so on and so forth, so how you are going to deal with that problem, what are the different models available to solve that specific problem. Is it clear to everyone? Okay. This is just an idea that in general, when you are running a four-stage travel demand model, what you are doing. So first, you are collecting some data from at household level. Then, using the household level data, you identify what are the travel patterns or the OD matrix. That OD matrix you are expanding, right? Because you have collected very small data, right, of 1000 observation, but actually you are representing a population of 1 lakh, right? So this 1000 observation, using this 1000 observation, you have developed 1000 OD matrix, but this is not true for 1 lakh people, right? So this 1000 OD matrix you have to expand for 1 lakh people, right? So once you have done that 1 lakh, expanded all the OD matrix for 1 lakh people, you will just validate it, whether whatever we are assuming is correct or not. How you are going to validate it? Screen line survey, right? We have discussed about screen line survey and cordon line survey, right? Using that information, if we see there is a problem, we are not getting a desired output, or we are not able to validate, that means we have to now adjust the OD matrix that we have expanded. Okay, we either have to change the regression equations or assumptions that we had previously, mode choice assumptions that we had previously, slightly we have to adjust them to make it valid, or to validate it with the existing data. Okay, once that is done, you just have developed a base year OD matrix. Okay, meaning base year, meaning in current scenario what is the travel pattern. Okay, once you have that information, what you are going to do, you are going to do forecasting. How you are going to do forecasting? You are going to use the information from the future, what will be the population growth in the future, how the land use pattern is going to change in the future. You are going to induce that into your model, recalibrate your model, and do traffic assignment, and all the four stages of travel demand modeling for the forecasted variable. Okay, so this is what we have explained in the flowchart diagram. So is it clear to everyone how do we perform all the four stages of travel demand modeling, and how the software is doing it at the back end? Are there any doubts related to any of these stages? Okay. Okay, thank you. So I will be stopping over here, and we have covered all the four stages of travel demand modeling. I think now Mr. Shashidhar will take over, and he will be explaining you with all these softwares. Okay, thank you.
So I hope most of you are ready with your network. I'll share few files. Anyone CR can just share in your group. Hmm? Vism data. So in the Vism data, there are two files. One is the details which you need for trip generation, trip distribution, and mode choice. And the second file, you'll have a basic network. So if few people they are not able to generate a network successfully, they can use this network for now for the analysis and just follow on with the presentation and demonstration. So yesterday we covered till the generation of PRT network. Yesterday we have covered till the generation of PRT network. So few people are asking me about the signal part. How do we generate the signal time and signal cycle diagrams? I'll just quickly demonstrate that before we move to the generation of private public network. So now at the any node where you need to generate a signal, just you need to double click on the node. You will get the node geometry. Hmm. I'm sure. So I was just saying, just double click on any node. So here you have the node geometry. Here you have four different legs. है ना? You have four different legs with the directions and turns. Now you just select the node, and after selecting the node, right click on this node, go to signalization and create signal controller. So I'll just go a little slow. Now here in the create signal controller, name and code you can give accordingly, and the cycle time is the total cycle time of signal, which means red plus amber plus green, red plus amber plus green of all four directions. In this case we have four directions, so red time, amber time, green time of four directions totally you will call the cycle time. So here there is an option called edit signal program. You'll see an empty signal program window. In this first, you need to go to signal groups and add signal group. Signal group is nothing but a combination of signals. Let us say you have four different directions. In the direction 1, you have straight, left, right. So the direction 1 straight, left, right will be signal group 1. And the direction 2, let us say east, north, south, west. For the north direction, straight, left and right will be group 1. For south direction, straight, left and right will be group 2. So based on the number of legs you are having in the junction, you will create the signal groups. Let us assume, not assume, but we have four directions, so we are creating the four signal groups. In the nodes you can just give direction of signal groups for just your understanding. And this I already told, the durations of each and every second, each and every color of red, green, amber, you can give it here. The intergreen matrix here, intergreen matrix is nothing but the minimum green time you wish from each direction to other direction. Let us say from direction north to south, what should be minimum green time? Direction north to east, what should be the minimum green time? And so on. So here we just need to give a basic minimum input for the software so that it can generate the signal program for you. Let us say we are just giving 45 seconds, means we are saying we need 45 seconds minimum from each direction to each other direction, so that you can see the movement of vehicles in all possible ways. So we have generated a intergreen matrix here. Now when we go to the stages are nothing but the sequence of green and amber. Let us say even if you are having 4 legs, there can be a possibility that at a single time you are turning 2 signals into green and 2 signals red. And in the second stage you are turning the other 2 signals green and the previous 2 signals red. In that case you only have 2 stage signal program. If you are turning each individual direction green, then you have a 4 stage signal program. So based on your signal program, you will assign the number of stages, and here you can actually select which particular signal you are turning green in which stage. So in the 4 stages, I have selected 4 different greens, and in the stage sequencing, you will sequence them after north, which direction will be turning green, and so on. So here you have cycle time, again here it is 60. We have what given there 160. So you need to update it and make sure that it is same. Now here you have two options, that is create the signal, create signal, create stage based signal program or signal group based signal program. So let us say we create a okay, even if you are not able to create it directly, here we can just select and change the cycle time, assign the offset time and switching time, and adjust it accordingly. And again the signal group 2, once this turns red, then the signal group will turn green. And so you place it accordingly, and similarly you do it for the remaining groups also. Then your signal group program will be ready. So again for the daily signal group program I am saying, if you add, let us say one you have designed now, which you can select it here, and the time which it should be operational, from what time to which time. And the second day you have, let us say if you have a different signal program, you will create a new signal program here and then assign that to the second day. Okay, clear till now? Any doubt, any more confusion? Okay, so yeah, we'll close this signal part here, and node you need to select it so that it will be applied to the corresponding junction which you are selecting. So once you are done with your private network, the second thing which we need to do is creation of a public transport network, where if you have a public transport in your city. So the creation of public transport is little complex. Because for public transport, what you need a public transport line, fixed line where the public transport operates, and the routes where the different routes of public transport, let us say the bus number or train number or metro number, which corresponding to a particular route. And then what you need is the fare system. What is the fare the public transport need to collect from the users, and the capacity of the public transport vehicle, and all these parameters first we need to define. I'll just go through quickly one by one. So under the network you have first is public transport operators. Operators are generally your SRTC or any municipal corporation which is operating the public transport system. You can just create the name, and then second you have public transport vehicles. So a particular operator might have multiple vehicles, है ना? So in a city there might be an express bus, an air conditioned bus, an electric bus with a different capacities, different speeds, and different operational parameters. So here you can create a vehicle unit, and then the transport system you assign bus. If you remember, we have created a transport system for bus, and the capacity of bus, generally the seating capacity is 35 to 40 and total capacity is around 70. है ना? So based on the model you're dealing with, you can use these parameters. And here you can also add the cost. What is the cost for empty trip, vehicle journey, layover, in depot cost, cost per kilometer for operating the public transport? These you will get from your data or the SRTC reports. So here I have already inputted few costs and parameters based on the data. If you wish to see this, ठीक है, should I move forward? So after that you need to design the fare system. So there are three different methods of fare calculation mechanisms which you have here. So you can select the consecutive path legs, single path leg, or all path legs. Consecutive path legs is with every leg or with every section adding in the route, the fare will be adding simultaneously. Single path leg means for every individual leg there is a single fare. So generally we adopt consecutive fare legs. Let us say the fare for initial 5 kilometers will be 10 rupees or 15 rupees, and after that every 1 kilometer they'll charge 2 rupees or so. So initial fare you can define here what is the initial basic fare. And here the city lanes we need to define, I'll tell you. And the transport system which are not operating on the PUT line are private systems. So all the private modes you have to select here. So again, if you go to the second tab, you have different ticket types. है ना? You generally have monthly passes, quarterly passes, one-day ticket or daily passes. All these kind of ticket types you can define here based on the frequency and what will be the fare according to those ticket types, and what would be the minimum fare All these you can generate here. Now what we are doing is we are generating a generalized fare for the entire network. Sometimes what happens in the high congested zones or in commercial zones or in central zones, the fare will be high, or in the zones which are outside or suburban areas where the connectivity is less and number of passenger demand is less, there the fare will be more. So there you can define different fare zones. Those fare zones you will be assigning here. So PUT fare zones, what will be, these are the stops which we have defined in the public transport. So based on these stops you can select, okay, stop number 1 to 10 will be on fare zone 1, stop number 10 to 20 will be on fare zone 2. This is just I am telling you as for your information. Later you can experiment it, but now we'll start with the public transport route digitization. So okay, once you are done with your private transport, if you scroll down here, you'll see few things, which is stop points, stop areas, stops, system routes, and system lines. So these stop points are the exact stops where the public transport vehicles will performing a stop, loading passengers, deboarding passengers, and then again they'll be starting from there. Stop areas are a small portion around the stop which is used to transfer the people from network to public transport bus. So these are the stop areas if you can see, and these are the stop particular points. And again you have system routes and system lanes. So now you go on lanes. First you will see an empty system lane. It will ask you to create a city bus. Are you getting a pop-up as soon as you open system lanes? There you just write a name as city bus. People who are using the network given by me, I think the public transport routes are already feeded. So first you need to create public transport stops or stop points. For that you select the stop points, click on add stop, and you can just add the stops wherever they are on any given link. No, for PUT we'll be creating different connectors. Yes. After you create the stop points, you need to create the public transport routes. And now, once you have created the public transport routes, then you will create the connectors to send people from your zone centroid to public transport routes. Okay, now once you have created the stop points, stop areas also will be automatically created for those particular stop points. Then you go for lines. It will ask for create line or line route. So line first you select and create a system, and then again you select a line route. Then it is asking which line is the line route for. Line in the sense, now here line is considered as a, let us say metro you have as a one lane, you treat metro as one line, city bus as another line, and let us say if you have BRT, that will be the third line. So transport segments of public transport are treated as a line, and routes are a specific routes where the public transport operate within those system or within those lanes. So here you can just give any route number if you have, or any name of the route, and the direction will be up or down, you can give accordingly. And transport system, as we have already defined as bus. So as you just click and drag on the stops, you can see that it is highlighted. This path is highlighted. You need to make sure that all the stop points which you have created are covered on this lane. And now a new route is created. So you can go to the list, line routes, and we have created this 101. And you right click on this and just click on generate opposite direction. The opposite direction also will be created, the direction down. So once you have created the route, you also need to create the vehicle journeys, which are the actual number of services which will be running on that route. Now here to create the vehicle journeys, there is an option in the timetable tabular. If you go to the timetable tabular, go to the line routes, select the specific route, and here you will find the create vehicle journeys dialog. You select this, and there is an option called regular services. So create regular services based on start and stops times. Let us say our services start at morning 8 o'clock and again on end at evening 8 o'clock. Regular service, what is the interval? Every 15 minutes, let us say. So once you give the time, the journeys are automatically added. And so you can see that 49 vehicle journeys are created. Just click OK. Now you can see the total schedule of each and every vehicle journey. Okay, so like that you create the number of journeys and also all the public transport routes which are available in your city, and then after that, after creating the all the public transport journeys, what you need to do is again you need to create the PUT connectors. So again PUT connectors, go to connectors, right click, create. The same way which you have used to create private connectors, PRT connectors, in the same way you need to generate PUT connectors. And the logic, as I was explaining yesterday, the kilometer maximum length of the PUT connector you need to keep in mind based on your width of zone, average diameter of zone. So if your zones are smaller, you can go with 1 kilometer, or if your zones are slightly larger, then you can take 1.5 or 2 kilometers, and maximum number you can put it as 3 and just generate the PUT connectors. Okay, once you are done with the creating the PUT connectors, then you need to again run the network check. So in the network check now you need to use the PUT parameters. So it will tell you if your network is inconsistent, there are any zones without PUT connectors, or there are any stops without lanes, lanes without stops, any all these kind of errors you can rectify here. Stop area, this it is showing PUT connector nodes without stop areas. This is used for what you call, this is used to interchange between multiple travel modes. Let us say we are here only using city bus. Along with city bus, if you have metro rail, the interchange between metro rail is used by that. So right now there is no need to worry for that. So is everyone clear till here and done with the public transport network till here? ठीक है. So few things which you need to set up before going to the demand model is the general procedure settings. In the general procedure settings, here you have all the predefined attributes and the functions which are used in the software to calculate, as sir was also explaining the trip generation and assignment related functions. Here you have different settings for PRT and PUT. For the private transport, if you go in the connectors, links, you have a volume delay function. If you remember this equation which sir was showing, to calculate the travel time based on the volume assigned and the maximum volume capacity of a particular link. So the statistic is given by Q max into C. Q is the present volume, existing volume on the link. Q max is the maximum volume permitted on the link, and based on this it will calculate. So there are various models of volume delay functions which you can use here, but the BPR volume delay function is a predefined function. And similarly, if you need to create different volume delay functions for different links, you can create it here. And To define any origin and destination, even in the trip distribution or assignment, what will be need is the impedance matrices. Impedance matrices are nothing but the friction factors which we use between two different zones. So we'll be calculating the skim matrices as a part of demand modeling. This particular section tells us what is the meaning of numbers in demand modeling in various skim matrices. Let us say, for example, after calculating a matrix, if you are seeing 9999 or 0000 in all your cells, that means that if no paths are there, then you give it as infinite. And if any OD pair is not existent, you give it as infinite. For travel time, initial or the free flow time, and travel time current, and similarly volume and distance and all other functions. So these, if you want to change the default values when there are no paths, then you can change it here. And again, you have the volume delay function parameters here for the private transport nodes. So those you can set it here. Additionally, the parameters related to public transport, which the software uses to calculate the impedances and functions, you can calculate it from here. And if you want to generate any user defined functions also, you can do it here. So these are the things which you need to done and set up it before. And then we are ready to start the demand model. So transport systems modes we have already set up here yesterday. You can recheck it once, the transport systems and transport modes and the demand segments. Now we'll go to the demand models. So you'll see an empty demand model here. Then you create a new demand model. And the type of demand model, here you select it as a standard 4-step demand model because we are using the standard 4-stage modeling right now. Now once you have created demand model, what are the different types of trips you have? What are the different types of trips based on activities? What are activity based trips? Home based trips, non-home based trips, home based work trips. There are different activities for which people are performing trips, and also there are different person groups who are performing these trips. So in the person groups, we can assume two different groups as of now. Now, how do we assume these person groups? What are these person groups? What is the need to assume these person groups? While you are going to generate your trip generation in the calculation of productions and attractions, let us say there are people who own vehicle and people who doesn't own vehicle. So the trip rates vary based on the vehicle ownership, right? People who are having a two-wheeler or car, they tend to perform more frequently and more number of trips compared to the people who don't have car or two-wheeler. And similarly, there will be a difference in employees and students. So like that, based on your assumption and based on your model requirement, you have to create two different person groups. You can create more also, but for the understanding, initially I am saying two. And then the activity pair is what is the activity they are performing the trip for? Home based work, home based education, non-home based work, or other category trips. So here also you create two activity pairs. And if you in the right side, if you press on create demand strata, it will automatically create 4 demand strata based on the combinations of your person groups and activity pairs. So this demand strata is nothing but people who are owning car and going for work. People who are owning car and going for education or non-work purposes. So these combinations make you 4 different demand strata, which means basically your overall travel demand has been divided into 4 segments now. So here in the productions and attractions, either you can directly feed in the productions and attractions. How do you calculate population into PCTR? If you have calculated it using any other method, using regression equation or any other statistical model outside of the WISM, you can just directly input it here. Otherwise, we will generate the productions and attractions. So similarly, for every demand segment, you have productions and attractions. Everyone has created your demand model. Did everyone create your demand model? Is anyone stuck at any step? Should we move forward? Now here there is an option called procedure sequence. So the procedure sequence is where you perform all the steps in the demand modeling. When you open the procedure sequence, so you can see few tabs here and you will see an empty procedure sequence, and there are few operational functions here for the procedure sequence. Here also you have general procedure settings, which we have already seen earlier. And here in the attribute selection, if you go to the attribute selection, edit attribute selection, you can see what are the default attributes the software is already calculating. The default attributes: start time, end time, duration. In PRT assignment, what are the demand segments and volume count, maximum minimum counts. All these kind of data you can see it here, and if you want to define any user based attribute, you can create here. So the first and foremost step which you need to perform in before starting a demand model is clearing the results and clearing the network. If you have run it previously any assignment, you need to clear those old results. For that you have initiate assignment. Now you can see I have run this demand model. I have some volume on the links. So go to procedure sequence, right click, add procedure. Here you will find in assignments, initiate assignment. Select it. There is no referent file and variant file. Variant file in the sense basically you'll select all because you have both PRT and PUT. So once I run this, you just add it and click on this run procedure sequence. Select this, make sure this is active and run the select procedure sequence. Now you can see all my assignment results are gone. है ना? All the assignment results are gone, means my network is now clear and ready for the analysis, ready for starting a demand model. Assignment successfully. Are you getting any error? So demand model, first you need to create a demand model, select standard first step, person groups, two person groups, name accordingly, activity pairs, two activity pairs, create demand strata, four demand strata are created, select the demand segments here, all the modes you need to select here in the demand strata. For each demand strata you need to select all the modes. Yes? Is everyone done with initiate assignment? So here in the messages, if you see a tick means it has been run successfully. If you see a red color mark means there is an error. If you see a orange triangle mark means there are some warnings, but still you can run it. I mean still it has been run successfully, but there are some warnings. Ideally you need to see a tick. Yes. Huh. Hmm. Already exists. ठीक है. Course. What is your error rating? PUT assignment, no demand set. Go to demand. Transport systems, modes, demand segments. Demand segments. Demand segment is like this. ठीक है, I'll see. Yes, this is fine. PRT, yes, click OK, and again PUT. हाँ. हाँ, yes, yes. Okay. So once you run the initiate assignment, then what you need is for demand model basically you need the skim matrices or the impedance matrices, which are nothing but the travel distance between zone I to zone J, each OD pair, and the travel time between each OD pair and the cost between each OD pair. So again add procedure, go to the demand model, sorry, not in the demand model, go to the matrices, and select calculate PRT skim matrix. Add procedure, matrices, calculate PRT skim matrix. So a procedure will be added for calculating PRT skim matrix. Here you need to give a reference stating that for which mode this particular skim matrix is being calculated, because if you remember, while you are giving the transport modes, you have defined different speeds for different modes, and on each road also there are different speed for different modes. So the travel time will obviously be different for two-wheeler and car, because some places you may also close the road for cars and only allow two-wheelers, so the distance also will be different. Select two-wheeler first, and while you double click on this variant file, it will show you a dialog box like this asking what to be calculated. So as now it is an empty network, first we need is a free flow time, and then we need a trip distance, and volume. Volume is not necessary, but basically what we need is the time and trip distance. So select this and click OK. And run this procedure. So you will see a matrix opening, something like this, which shows the impedance or your time or distance. And this matrix should not be 0, it should have, so this is my particular distance matrix for two-wheeler, which shows the distance between zone 1 to zone 2, 1.78 kilometers, zone 1 to zone 3 is 2.99, and similarly you have the rest of the values. Are you able to run this and generate skim matrices for two-wheeler? Yes, no, error. So we have calculated the PRT skim matrices. Now similar to PRT, same logic, but there is a slight difference for the PUT skim matrix. So the skim matrix calculation is under matrices, not the assignment part. Under the skim matrices, you have the PUT skim matrix. Now for the public transport, what is happening is you don't have time based or distance based impedance functions, but you have a timetable based impedance function. As we have given a timetable with the starting time and the ending time of the service, headway and the frequency, we have generated different vehicle journeys. So based on those vehicle journeys and the timetable, we'll calculate the PUT skim. Once you add the procedure, go to the reference. In the reference, select the demand segment and use a timetable based PUT skim matrix. And run the procedure sequence. So you will see a PUT skim matrix generated. This shows the zone wise time required for traveling in a public transport. From zone 1 to zone 2, it takes almost 25 minutes, and similarly from zone 1 to zone 3, 40, and so on. Is anyone working with your own network, or is everyone using the network file which I have shared? कोई यूज कर रहा है अपने नेटवर्क? हाँ. So if anyone has your own network, try to use it, because the errors which you will be getting are specific to each and every network. Which I have shared, I have cleaned it and I have solved all the issues and shared. So if you use your own network, then you'll know how to solve the errors or what kind of issues you might face. Okay. So now we have calculated all the PRT and PUT skim matrices. Now there is one more step called combination of matrices and vectors, because now all the functions which you have calculated are individual for each and every mode, but for the distribution what we need is a combined travel time friction function which can be used for all the zones in the distribution. So for that we have one step called combination of matrices and vectors. So again, if you go under the matrices, you have combination of matrices and vectors. Select that. So here you have a small formula based on the interface of the Vism. Here you just need to write matrix code is equal to TTC weighted in inverted commas, and matrix type is equal to 4. So we are just saying that we are defining a matrix called TTC weighted, which is a demand matrix. Matrix type 4 is a demand matrix. And then you have a semicolon. After that is equal to where you are actually giving the formula that it is equal to matrix bracket open demand segment code C, which is car, and code travel time cost, and matrix type is equal to 4. So this is the combination of car and travel time car. We are creating a new matrix called TTC weighted, travel time car weighted, and matrix type 4 means it's a demand matrix. So is everyone able to run the combination of matrices and vectors? After this combination of matrices and vectors, we'll start with the trip generation. Now, how these four stages are linked to each other? First, we need to put this generation. For this generation, we need this production rate and extraction rate. And then after this generation, we use the same matrices which we have calculated and the utility function of cost per distance with and based on that we calculated it. Now, once we have the then we go to the mode choice using the choice based utility function. And then after that, once the demand variable is aggregated for each and every mode, combine the demand into mode and do the okay. So you need to remember steps in the mind while you are running each and everything, and then you will understand how these are. So once you are done with the combination of matrices and vectors and generating the TTC weighted, now the next step you need to add is the trip generation. So go to create procedure. In the demand model, under the demand model, add procedure. Under the demand model, you will find trip generation. Under add procedure, demand model, you will find trip generation. Add the trip generation. So after adding the trip generation, in the reference, you need to select the demand model 1, or you can select all the demand statums if you have a demand model. And Once you open the variant file, you will see something like this, where you need to define production function and attraction function. So here what you need to do is, I have given you the production and attraction function equations in the Excel file which I have shared with you. These equations are a realistic production attraction function equations, but not based on the actual data. Once you open the Excel file, I'll explain what is the meaning of this particular equation. So here in this data which I have shared, in the first sheet, in the first sheet, you can see the zone ID, and corresponding to each and every zone ID, you have the EC, which means employee car, ENC, which is employees without car, S2W, which is student two-wheeler, and SN2W, which is student with no two-wheeler. So basically these are the four demand stratums. I have assigned a label to the demand stratums as per the model, and population is the total population of that particular zone, and two area attributes I have given you, which are commercial area and public semi-public area. These are the land use attributes of the zones. So now if you go to the second tab, which is strip generation, here you have the production and attraction equations which you need to input in the strip generation procedure sequence. So here for the home work trip, which is the demand segment 1, AP1 DS1, in this case, the demand stratum, the first demand stratum, which we are calling as home work trips, I have given a production equation of employees with car into 0.85 plus employees with no car into 0.8. So here what does this mean is, the working population who own a car, they are going to make slightly, the working population who own a car, they are going to make slightly higher trips when compared to the population or the employees who does not have car. And here we don't have any student population because they generally don't travel for work purpose, they travel for education purpose. So in the production equation, you need to give EC into 0.85 and ENC into 0.8, which is nothing but first and second population. Go to the production function, select this variable attribute, sorry, not variable attribute, zone attribute. In the zone attribute, if you scroll down, you will find the user defined attributes. So here the demand AP1 DG01 is the employee with car population, This is the employee with car population into 0.85 is the PCTR rate which I have given here for the employees with car, plus again call the attribute, simple attribute zone, scroll down to see the user defined attributes. AP1 DG2 is the employee with no car, into 0.8 is the PCTR fit for employees with no car. So this is the production function for demand segment 1, which is home based work trips. And for the simplicity, as of now, what we are assuming here is the PCTR would be same for each and every zone for a given demand stratum or demand segment. So these user defined attributes are nothing but whatever you are seeing in the green are the system defined attributes which are basically pre-fitted in the software. User defined attributes are these data which you are manually adding it to the software and you're saying, okay, these values I'll use somewhere in the calculation. I have not changed the name, but AP1 DG1 is nothing but the population of employees with car. AP1 DG2 is the population of employees without car. And these 0.85 and 0.8 are respective per capita trip rates, which are nothing but the number of trips made by a person, average number of trips made by a person for that particular demand group. So is everyone able to call the attributes and input the multipliers or PCTR rates? Now, once you have given it for a single demand segment, then you just click on OK and move on to the next demand segment. So the second demand segment which I have named here is home education. These are nothing but the trips which are starting from home and going for education. Here we have student population. So student population with two-wheeler and without two-wheeler are in your VC model defined as population of activity pair 2 demand group 1, activity pair to demand group 1 into 0.9 plus activity pair 2 demand group 2 into 0.75, which means here we are trying to say that people who own two wheelers make slightly more education trips than people who doesn't own two wheeler. So now these assumptions and these rationale which you form behind your demand segment comes from your data which you collect in the field, and when you see the correlation between the variables in your data, you will understand where the correlation is high and which variables you need to segregate into different demand segment groups. Now after inputting the production function for trips from home to education, next we have the trips from home to shopping. So if you observe in the previous two demand segments, in the work there are no student population considered, and in the education trips there are no working population considered. But in the shopping trips, here we have both the employee population and also the student population in the production function equation. Because shopping, both of them can perform shopping trips. And similarly, in the other trips also, we have all the population groups in the production function. So here we have just segregated the number of trips made based on their socio-demographic characteristics and based on their purpose. And the combination we are using it to calculate the number of trips under each and every activity pair. Is everyone clear? Hmm. This is the production function for home-based shopping trips. So just try to relate the names of attributes with the names I have mentioned in the Excel sheet. The population of AP-DG01, AP01 and DG01 is population of employees with car, and population of AP01 DG02 is population of employees without car, and the population of AP02 DG01 is population of students with two-wheeler, and the population of AP02 DG02 is population of students without two-wheeler. So are you guys able to add the production functions for all the demand segments? Here the production we are trying to measure with population by multiplying the population into trip rates. And now when we come to the attraction, so beside the production function, you'll also find the corresponding attraction function. You can just switch it using this production rate and attraction rate, or else you can directly open it. And in the attraction function I have given is commercial area into 1000 plus public semi-public area into 800, which means I'm saying that for every unit of commercial area, 1000 trips are being attracted, and similarly for every unit of public semi-public area, 800 trips are being attracted. So now here you call the attribute of commercial area, which is a user defined attribute, into 1000 plus the user defined attribute of public semi-public area into 800. Like that you need to define the attraction equations for all the demand segments. So for first demand segment it is commercial area into 1000 plus public semi-public into 850, and for the second demand segment it is commercial area into 1250 plus PSP into 300. Now this attraction equation can also be same for the all demand segments, but your attraction equations generally does not vary based on the demand segment. It varies based on the TAZ, traffic analysis zone, based on the type of commercial establishments, by which I mean if there is a shopping mall, the kind of population or the number of people it attracts is very much different from, let us say, a general store or a grocery store kind of a commercial establishment. So I am just giving a generalized calculation equation here. Other than that, if you have a TAZ wise attraction rates, TAZ wise different attraction rates, you can calculate the attraction rates out of the WISM and input the attraction and production rates as I have shown while creating the demand segment. Everyone fill the production and attraction functions? Yes. Now close this, click on OK and run the trip generation. So after filling all the functions, click on OK, click on OK, and run the trip generation. So after you run the trip generation, when you go into the demand strata again and click on productions and attractions, you should be able to see the production and attraction numbers over here. You must be able to see the production and attraction numbers over here when you go into the demand models, demand strata, and productions and attractions. So once you have run this, are you able to see the productions and attractions, some numbers in the productions and attractions? Yes. So here your trip generation is complete. Now you have the number of trips being produced and the number of trips being attracted for each and every zones. Next step what you need to do is trip. What is the second step after trip generation? Trip distribution. For the trip distribution what you need? You need the friction factors between each zone, each OD pairs, and also you need the distance between each OD pair. And for the trip distribution, the input which will be needing from your survey or from your primary data is the TLFD. What is TLFD? Trip length frequency distribution. How do you calculate trip length frequency distribution? How do you calculate trip length frequency distribution? Yes, it is nothing but the number of trips being performed for each and every kilometer. Let us say 1 kilometer, 0 to 1 kilometer, what are the number of trips? 1 to 2 kilometer, what are the number of trips? And so on. Now for this, to calculate these friction factors, you have a procedure called estimate gravity parameters under the demand model. Under the demand model, estimate gravitation parameters Calibri. So you need to estimate the gravity parameters for Calibri differently for each and every demand segment. And when you open the variant file, here you will see a empty column. Here you need to create a class interval based frequency distribution. So this class interval based frequency distribution, I have given you the frequency distributions in the Excel TLFD form. So these TLFD frequencies or percentages you need to input in the Calibri based frequency distributions, and after giving the percentage share for each and every kilometer trip, you should be able to see the number of trips automatically under each class interval if your productions are generated correctly. है ना? Add procedure, demand model, estimate gravity parameters. So first you create a utility definition. First create a utility definition, then go to the distribution. In the distribution, create classes, edit from to values, and input the share. So 0.16 I have given here, 0.16 if I put here. So automatically I am getting, there are 2876 strips which are in between 0 to 1 kilometer in my demand model for this specific demand stratum. 16% means 2876 strips are falling under this specific class. ठीक है, so I have given you 4 TLFD distributions. Input the 4 TLFD distributions under their respective demand segment, and then we can run the estimate gravity parameters. So basically these estimate gravity parameters, based on the distribution we are giving, it will transform the distribution into the entire matrix. It will transform the distribution into the entire matrix, and it will say, okay, if let us say there are 10 OD pairs within distance 0 to 1 kilometer, in those 10 OD pairs it will distribute 16% of trips. है ना? And if there are 20 OD pairs of distance 1 to 2 kilometers, it will distribute 25 or 24%, whatever that percentage we are giving, in those 20 OD pairs. Are you able to understand? So first you need to add utility definition, create a utility definition here, and then add the distribution. You need to do it same for the 4 demand segments. And run the procedure sequence. This will not create any direct output matrix, but it will create a friction matrix which will be saved in the software, which we'll use in the further trip distribution calculation. So you can input the distribution triplet frequency distributions of all demand segments and run till there. Here we'll break for lunch. You complete till there, and in the afternoon we'll just quickly see distribution, mode choice and assignment. Were you able to run the calibrate steps? Sandeep, hand mic. Hello. So are you guys able to run this calibrate distribution parameters? है ना? कितने लोग को हुआ? How many people were able to run it till calibrate? What is the error? Close it once. The number of trips minimax interval has to be zero. Generation failed. Okay. Open this. Show me the distribution. This also to be zero. है ना? 0 kilometer, less than 0 kilometer, no trips, right? Will come down. So after estimating the gravity parameters, the next step we have is the trip distribution. Create a step using the procedure sequence, add procedure sequence. And under the demand model, you have trip distribution. So add trip distribution. And in the reference, you will select all the demand segments because we can run it at one go for all the demand segments. In the reference file. And here, in the utility definition, what you need to do is, what are the parameters that you have in a utility function? What are the parameters, x parameters, which you have for the beta variables? Okay, distribution. So distribution, basically you're trying to do it based on the either distance or either travel time. है ना? Here in the utility of distribution, what you need to give is Distance matrix, OD distance matrix, which we have calculated using the skim matrices. So you just open the utility tab, and in the utility tab, just directly select the distance matrix of car. And similarly, you select the distance matrix for all the demand pairs. So here, after selecting the utility matrix, then there are three variables A, B and C. If you open the function graph, these are nothing but the disutility functions of distance. So here you can see the generalized distribution function, which is the function of utility between zone I and zone J, is in the general form of e power c into uij. So this c is what we are trying to fill in now in the trip distribution. And as we know that c, we generally have a negative value. So based on the assumption, we can consider minus 0.2 and minus somewhere between minus 0.2 and minus 0.3. है ना? This is the weight which you are giving to distance, which means that how much people would be able to, how much people will be avoiding a particular route if the distance is more. So for all the demand pairs, you give values between minus 0.2 and minus 0.3. Right now, and you can visualize the function graph here. I think default it is logit, so you can let it be logit. The default function defined by Vissim will be logit, so just let it be a logit as of now. So here there are two options. It is asking whether to constrain production or constrain attractions. So it will balance the other based on what you select. Until and unless there is a major difference in your productions and attraction, it is fine if you select either of these things. And if you wish to use a doubly constrained matrix balancing where you have the iterations, sequential iterations, then you can use the doubly constrained matrix balancing procedure with number of iterations. But otherwise, if you just want to run a basic model, then use either of production or attractions. And then you run the trip distribution model. So after running the trip distribution model, you should be able to see the I think I have changed. Huh. So after running the trip distribution model, you should be able to see the OD matrices. So three OD matrices for public transport, for private two-wheeler, private car, and public transport will be visible after you run the trip distribution. You'll see a demand matrix something like this between zones, which has number of trips for each demand stratum. No, sorry, right now you will not get the modes, you will just get a combined demand matrix because we are just at the distribution. The mode wise matrix you will get only once after running the mode choice model. ठीक है, हुआ run? Are you guys able to run? Estimating gravity parameters while adding the TLFD, you need to make sure that in the first class interval of TLFD, there should be only 0 and the probability also should be 0. And in the last column, last class interval of the TLFD also, there should be the maximum value, let us say 7 or 8 in your case, to max, and the probability of it also should be 0. Basically, the probability of first class and last class should be 0. They are the extreme ends of your estimate gravity parameters TLFT. So here I have given you, for the purpose of simplicity, I have just given 1 kilometer gap, but sometimes your TLFD might demand 0.25 kilometer precision if there is a higher variation of trips within 0.25 kilometer variation. For example, in that case, what you need to use is 0 to 0.25 kilometer, 0.25 to 0.5 kilometer, 0.5 to 1, and so on. So once you run the trip distribution, just open the matrix and check if there are any abnormalities or zero values or 9999s in your matrix. If the matrix look fine, then we can proceed for the mode choice. So basically in the mode choice, what are we trying to do? By the end of distribution, we just have the matrix of number of trips going from each origin I to each destination j. So for each OD pair, we have the number of trips which will be going, but we don't know what is the share of modes of those each trips. So now our task is to say or to estimate the number of trips each mode wise. Let us say, for example, 1000 trips are going from zone 1 to zone 2. In that, how many trips will be made using two-wheeler? How many trips will be made using car? How many trips will be made using public transport? This is what we need to define in the mode choice. For that, there are two methods to do. One is directly inputting the utility equation in the software, and the second is if you have already generated utility equations and probability shares for your city using the nlogit output or any MNL model output, then you will have what should be the percentage of car, percentage of two-wheeler, percentage of public transport. In that case, what you can do is directly input the demand matrix and multiply with the percentage. Okay, so both methods I will tell you. Now, what is the importance of directly inputting utility equation? Why can't we just simply give the probability percentage? Yes. Why do we need to input the utility equation? Why can't we just directly take the probability percentage? Mode choice group. Choice modeling कौन किया है? Who did the choice modeling? Fast. हाँ. Why do we need to input the utility equation? Why can't we just directly put the percentage share? Hmm. Travel time, travel cost, everything you have, but at the end you will just derive the percentage of vehicle share, na? So what is the need to input utility equation? Oh, that you have, based on that you are getting the probabilities, right? E power u by e power u, u of car plus e power u of two-wheeler. Then based on that you are calculating the percentage, right? Predicted mode you have. So your model is saying 40% car, 40% two-wheeler, 20% public transport. This is what you want output. Then why do we need to input the utility equation in the software? Why can't we just directly put 40%, 40%, 20%? Because what we do is in sample survey, what we do, we only capture few sample, है ना? So in that few sample, we cannot see the behavior of everyone. If we only just input the share, what happens is the distance between two different zones is varying for every OD pair, है ना? So based on that distance, the utility function will act differently because the distance is changing. The predicted mode will change. Okay, so to account that variability, we input the utility equation here. So in the procedure sequence, add procedure, go to demand model, mode choice. I am just right now just telling you the simple mode choice. Choose all the demand segments. Now here in the variant file, you need to input the utility. So utility, you have various parameters: travel distance, travel time, travel cost, and you have beta coefficients which you get from nlogit or any multinomial logit software. Now using those beta coefficient, let us say minus 0.4 into travel distance of two-wheeler minus 0.2 into travel distance of, sorry, travel time of two-wheeler. Okay, so like that you just replicate the utility equation. Now, as we don't have the data of utility equation, I'll just tell you the probability based method. So in the probability, you just, this is what? Activity pair 1 demand group 1. You have the distribution matrix of activity pair 1 demand group 1. Directly select this distribution matrix of activity pair 1 demand group 1. Just multiply into 0.2 wheeler. What is the probability? Let us say 35% are two wheeler. 0.35, yes. And similarly, what is the probability of car? Input the distribution matrix of demand segment 1 into 0. Let us say 40%, 75. Here we have given 35, here we have given 40, 75. 25 is left. Again you select demand segment 1 into 25%. Okay. So now the activity pair 1 demand group 1 demand has been split into three modes: two-wheeler, car and public transport, with a distribution of 35% using two-wheeler, 40% using car and 25% using public transport. Now when you are actually doing it for your exercise, you need to modify these values according to the output of the demand model, or either directly input the utility functions. So for the utility function, you have the coefficient, beta coefficient. If you are need to input the utility function, beta coefficient into travel time matrix, beta coefficient into travel cost matrix, plus beta coefficient into distance matrix. And similarly, you need to input the probability share of trips for all the distribution matrices. So like that you have four demand segments, demand stratums, means you will get four distributions, and each distribution has three different mode shares. So 4 into 3, 12, total 12 values you need to input, four different matrices, and each matrix into the probability of three different modes. So like that you need to fill all these variant files here in the utility function tab, and then run the mode choice. And then run the mode choice. So after the mode choice, you will see the mode choice matrices, vehicle wise mode choice matrices for each and every demand stratum. vehicle wise mode choice matrices for each and every demand stratum. So I have just opened the two-wheeler matrix now. And in this matrix, you can run the matrix arithmetic operations also. On the top of this matrix editor, you have all the basic arithmetic operations and also advanced algebraic functions and diagonal functions. So if you ever need any modifications in any matrix, then you can use these options. While you're giving the mode choice probabilities for each demand stratum, you need to make sure that the sum of the probabilities will be 1 for each demand stratum, not total 12 values. For every set of 3 values or 4 values, if you have 4 modes, in this case we have 3 values, the sum of these 3 values for each demand stratum should be 1. है ना? Basic probability theory. Done? The number of trips from each zone to each other zone, all the OD pairs of ij. So now we have the data of matrices of mode wise, demand stratum wise distribution from each zone to each other zone. Now what we are left is only with the assignment. The assignment will be run using the volume delay function based on the capacity and traffic volume being distributed. As sir was explaining, there are few methods for the assignment, like all or nothing method, equilibrium method, and incremental assignment method. So once you are ready with the mode choice matrices, before going to the assignment, there is a small step. Move to the next step. So now you are seeing 12 different matrices in front of you for 4 different demand stratums and 3 different modes. But for running assignment, what we need is mode wise distribution matrix we need between all the OD pairs. है ना? Are you able to run? So now you have 12 matrices and now you want mode wise matrix. How do you do that? I have each demand segment wise, each mode wise matrix, and now I want only mode wise total demand. How do you do that? I want all two-wheelers at one place, all car demand at one place, and all public transport at one place. क्या करना है इसमें? How do you do that? Simple. Can you add the matrices? Can you add all the demand matrices of two-wheelers? Can you add all the demand matrices of car? Huh? Combination of matrices and vectors. So in the procedure sequence, add combination of matrices and vectors, add procedure, matrices, combination of matrices and vectors. Don't use the code same as it is because the matrix numbers might be different in different cases. But yeah, just matrix code is equal to two-wheeler and matrix type is equal to 3 will be same. And after that, you add your respective demand stratum matrices of two-wheelers. है ना? Just go here, add this, and then plus add this, and then plus add this, plus select this. Right? Matrix code is equal to inverted comma open total two-wheeler inverted comma close and matrix type is equal to 3, and semicolon is equal to, from there you select the respective all two-wheeler matrices of mode choice. All two-wheeler mode choice matrices. Okay, then you run this. And similarly, you make a combination of matrices for car and public transport also. Once you run this, same thing need to be done for car and public transport also. So done with the combination of matrices. So you have done with the combination of matrices, then you will see the total two-wheeler and total car matrix. So the total two-wheeler, total car and total X, matlab public transport matrices you will be seeing here after running the combination of matrices. Basically, you are trying to add all the demand of each mode and bring them at a one place before assignment, because we need to run the PRT and PUT assignment. So yes, once the combination of matrices is done, you have the total two-wheeler and total car here, and total public transport also you will get once you run it. So go to the procedure sequence, create a procedure of PRT assignment under assignments, and here in the reference you select two-wheeler or car first, and then the remaining one also you select. You need to run the assignment separately for two-wheeler and car, and the type of assignment you can select incremental or equilibrium using LUC and any other different method you need to use, you can select it from here. And similarly add the PUT assignment, make it a timetable based assignment, and just run the model. Uh-huh. Yes, yes. Okay. So once you are done with it, you will get a network something like this, which is loaded with the number of trips in each link of public transport and private transport. You can edit the graphic parameters and add the legend and everything from the graphics tab of here. So rest you guys can try and run the assignment. Now we'll have a quick question answer session and then we'll close.
Yeah, till here we need to end with this trip assignment one. That will be the four-stage modeling. So you practice it once again and watch the video and repeat the exercise. That will be your end wala assignment in this particular subject for MTP. Now we can have a Q&A session. Any doubts from this four-stage modeling or travel demand modeling or anything from transportation planning you can ask, which is related to next sem you are going to choose your topics of thesis and all. So you can ask any research related or any project related doubts. So they will be answering. Sir, please sit here. ಇನ್ನೊಬ್ರು Any questions from B plan? You can ask. This will repeat after some time. This will have after some time. Actually. Any doubts from MTP for us? You don't have any? Anything from B plan? From your studio? Transportation planning studio? Vijayawada TMP. Any doubts? No? We are busy with this one. For their oral comments or some suggestions.
No, it's fine. I guess. Two lines. Two lines. क्या बोलना? Two lines. How is your experience?
So, okay, everyone. Thank you for paying attention and listening to us. I hope you had a interesting session. The software part was handled by Shashidhar, and I guess he has covered all the four major aspects of four-stage travel demand model. In addition to this, in terms of theoretical aspect related to four-stage travel demand model, or in general any transportation planning related problem based on your master thesis, or based on any of your projects that you are planning to do in future, you guys can contact us. So I think in the first slide, I will be sharing the slides as well. In that, my email ID is there. So you guys can just drop me an email or to Shashidhar, and we would be happy to help you out. Okay, thank you.
Sasi, you want to speak some? Please say a few words.
So it was a nice session, but if you have any doubts, you can approach me. First, you try to solve among yourselves. फिर भी नहीं हो रहा है, even you are not able to solve that, then you mail or contact me. ठीक है? Okay, thank you.
Planners, any doubts? No? Fine. You should try to practice the procedures and all. Already we have covered something. So better you keep on practicing, then only you will be remembered. Otherwise it will be gone. So you redo from starting. So all these 2 days exercise, you need to start from starting point of building network to trip assignment till the last stage. Otherwise, the student won't be sufficient. Softwares are like that. Whether it can be GS or it may be Vism or it may be Cube or any software, any logic and all. If you keep on practicing, then only you will be get that point of you get to used to the software. Otherwise it will be difficult after only for the studios or only for the subject base we are learning. The next semester you will forget again. You need to go back and watch the video and see the things or not. Next semester should also can be use Vism. So next step ke liye I suggest ki you go ahead with the cube for TP. This Vism, I think you got the procedures. In cube you need to use the Python little bit. You can change the algorithm and do the iterations accordingly in cube. And any logic you can also practice. It is also openly available. Yeah. Yeah. Sesi.
Sir, I was asking about isoprods.
Isochrones.
Yeah, so one actually 9 of telling out that isoprod is easy to make.
Wait for some time. We'll have picture. And I suggest you to install and practice it for some time. It won't be useful for at this point of time, and it will be useful in future. This software of Visum. You can apply. We can start implementing in your studio also. Not you. It's not TMP. Traffic management. It's for small areas. Corridor level and zonal level. Picture that same place.